also about how many IOPS you want to get, how quickly what latency you need. You're paying for licensing. So you still have to license your Windows servers. You still have to pay for licensing for your SQL servers. And then also, what if you need HA? What if you need DR? So you're paying all of those costs for your HA replicas, all of those costs for your DR replicas. Another thing I didn't put on this slide, but it applies to both. If you're taking any of that data and you're extracting it, right, going to on-prem or moving between clouds, you're often paying like data egress charges, data ingress charges. So these are all things you need to be aware of and factors that you need to control through your performance tuning. Now, on the PaaS side of things, when it's platform as a service, some of these things are managed for you, right? They're going to look more expensive per hour. And things like Windows licensing or operating system licensing, the SQL licensing, sometimes the cost of those HA replicas is built in. So primarily there, you're paying for the compute. So again, the CPU and memory tied together. And again, your storage. And here too, it's the same thing where you're paying for both the volume that you need and how many IOPS or what speed you need. So any questions, thoughts on this? Yes, Ross.
Yeah, when we started going into getting involved with yes.
Yeah.
It was out of control. You'd have some department that would say, hey, we need an Aurora database, which is souped up Postgres.
Yeah.
And the RDS version of Postgres. And so they would go to the platform team that does all this stuff and creates all this stuff with Terraform. And we as DBAs, we're not even in the loop. Now, that's great, but then all of a sudden, the accounting gets the bill for all this. And then they come to us.
They see you as the managers, the stewards of it.
Yeah, or we're supposed to be.
Yeah.
And we gotta tell them, hey, never heard of this.
Shadow IT is real.
Yeah.
Yeah.
It's for all. Yep. Yeah, so pay attention to pricing, right? Every cloud is going to have their pricing calculators available to them where you can go and spec things out ahead of time. I just grabbed some screenshots even from the Azure portal looking more at the managed instances, but here we're looking at like SQL database and SQL managed instances. We're looking at the vCore where you pay per core model. And you can see as you go through and select things, you can see you're paying for cores, you're paying for your storage. And this, because I picked this business critical tier, which I'll talk about later, right? That's even more expensive than other tiers that has like multiple built-in replicas for built-in high availability and built-in read scale. So make sure you're just comparing, all of the options you have, what that pricing is like. So again, main topic of this, how are we going to maximize our investments? First thing I'm going to say, right? You have to be able to know how much work your queries do. You have to know what your specs are, right? Especially, again, think about a couple of clients I'm working with right now. They have these on-prem SQL systems. They have very big physical servers. They're still running physical hardware, flash storage arrays, and they're essentially saying, we don't think this performance can be replicated. And I've had to really dig in with them to go, okay, but I need you to tell me, like, I know you have X hardware, but what IOPS are you getting out of that? What is your latency on that? How long are your queries taking to run? Because oftentimes when you think about it, there are not specific hardware to hardware measurements in the cloud. They might be able to order something and get it delivered to their data center and have it set up in a couple of months versus something like hardware wise that's not available in Azure or in AWS or in GCP. So you really have to know, you really have to have data. You really have to have those metrics. You really have to have good baselines to understand what work you're doing. And when I think about that, right, all of the tools that you're using normally in SQL Server are going to be available and are going to be of use to you for tracking this. So think about things like all of your DMVs for tracking performance. I'm working heavily with this customer on like sys.dbio virtual file stats, right, to help them understand exactly how much every file on every drive is doing. What are the busiest ones? Where are they going to place those in cloud storage? And again, with your actual workloads, this is right. So use your tools like your execution plans, your DMVs, using Query Store. A lot of other third-party monitoring tools connect to SQL, connect to Azure SQL. So you have to start with that baseline of understanding how much work you're doing.
Anyone here use Perfmon? Performance monitor?
Yeah.
So there's actually a SQL counter in Perfmon that keeps track of all of your queries that have executed since the server's been last restarted. And it keeps, they have to have finished, right? But it keeps track of them in essentially duration runs. And so at any point in time, you can get a quick and easy baseline of, hey, what's my system look like in terms of how long are my queries taking without having to, you won't see the actual query detail, but you'll know, hey, X% of my queries are taking between 10 and 20 seconds. And that's a good way to go and understand what your baseline is for your query without having to go and actually set anything up to do it.
And again, so these are all tools you can use right on-prem SQL Server. And
Do you ever find these days, I haven't tried it in a while, that Query Store doesn't work for certain workloads, like high transaction workloads? Or can you use Query Store anywhere nowadays?
Query Store, right, they've done some work in the last couple of.
I was excited about that, but they didn't do it how I expected. I thought you could be able to filter things, but it's more of a size control.
It's more of a size thing. So yes, Query Store does have to take and gather your data and write it to these memory tables and then put it out to disk and persist it. And yes, if you have a very high transactional system and you're trying to capture everything with Query Store, there are, yes, possibilities that Query Store cannot keep up, or depending on your settings, can fill up. Again, I work with customers that are running high transaction financial services systems and using Query Store. And I don't see problems on a regular basis with it anymore. With that said, Query Store has a lot of configuration options that may need to be adjusted on high transaction systems, right? I'm not going to run my query capture mode all in my highest transactional systems. The other thing I've seen a few times is customers that want to keep 3 months worth of data in their Query Store. And then all of a sudden you get these very massive tables with a lot of bloat, and it's taking them so long to query the Query Store data that they're not able to use it effectively. And that's also kind of something that you have to address. So those are kinds of the things I've seen. Yeah. But yeah, any version of SQL, whether you're running SQL, SQL 2016 or greater in a VM on-prem in AWS, if you're using Azure SQL Managed Instance, Azure SQL Database, the Amazon RDS version, they're all going to have these tools available, right? So you're going to be able to use all of these internal tools in SQL Server, regardless of where you are. Who here has Query Store turned on all of their SQL databases, or at least a majority of them?
Do it.
Okay. I still think like Query Store is probably the best feature we've released in SQL Server in the last 10 years. I do not see, and like, I don't see any reason not have it turned on for your databases. I think it is the best troubleshooting tool that exists. I highly advocate for it at all of my.
Scared.
Well, what are you scared of? I feel like we're gonna have a little bit of a therapy session here, which is good.
I don't mean to get you off track. 'cause
No, I'm gonna be talking about Query Store some more later, so let's come back to that. Yeah,
I'm scared. So I work in a healthcare group.
Yeah.
We have an electronic health record system that's taxed and has no room for performance degradation. And I don't have a good place to test.
So think about it like this. So
And it's, in the past, when I tried it, it caused an outage. And so I got like.
typically about 1 to 3%, set the capture mode to auto instead of all.
Yeah.
But the benefit that it gives you for being able to troubleshoot queries whenever something goes awry versus not having that insight.
Yeah.
Far outweighs.
And I'd be interested in hearing later how it tanked the system. Cause it can, but that means typically non-default setting.
I haven't seen it happen in all my years.
So definitely something we'll follow up.
Yeah,
on
this is like,
A little bit later.
when I ran into a problem, there was years and years ago.
Okay, yeah. All right, so again, that first kind of thing is what we're talking about is your baseline, right? Perfmon, if you're running VMs, just capturing data, making sure you know how much. So that's the first step to performance tuning, making sure everything's running well. Now, the second thing we're going to be working on a regular basis is monitoring resource consumption. So everybody has a monitoring tool for SQL Server set up. Yes. Okay. There's lots of options out there. And even if you aren't buying specifically a, third-party monitoring tool, right? A lot of companies kind of roll their own, right? They use built-in DMVs, activity monitor, SSMS reports, SQL, extended events, that sort of thing. One thing, I wanted to, again, mention some things that exist only in some of the platform as a service offerings that are, not necessarily in SQL running in VMs or just SQL on-prem. So if you're running Azure SQL database, there are a couple of very specific DMVs to that service that can help you even further diagnose your performance. So there's one called database resource stats that runs per individual database. And for one, it's going to store data taken every 15 seconds for the last hour. And what it does is it looks at all of those kinds of caps in your, right? So when you're running a platform as a service offering, you have max number of CPU, max amount of memory, max IOPS, that sort of thing. And it captures at what percentage of those you're running at any point in time. So this is often a really quick troubleshooting tool I can use if I'm hopping on a call where it's like, well, the SQL database performance has just tanked. I'm like, okay, run this from sys.dmdb resource stats. Which of your resources is the one that is constrained here, right? This very quick method to diagnose where we should start without necessarily waiting 15 minutes to capture the latest weight statistics. Like here, we just know it's CPU bound or we know it's IO bound. There's also another view called sys resource stats. So it's stored in that logical SQL Server master database. And it samples every database on the server once every 5 minutes and stores that data for about 2 weeks. And that does kind of the same thing, right? So it captures very similar max CPU usage, IO connections. That one's good if if you're kind of rolling your own performance tuning, if you're rolling some of your own monitoring tools in Azure SQL database, grab that, persist it off to your own table, be able to build just kind of this view of what your average percentages are. Another thing I like to use that for. One of the things that we run into in the cloud is hitting the limits, right? We are CPU bound. We're constantly spiking up CPU to 80%, 90%. Those are the kinds of issues that I get involved with customers, or the IOPS isn't fast enough, we're not running enough storage. Conversely, when you have a database in the cloud, you're paying for that CPU every minute. And if you have 8 CPUs or 64 CPUs or 128 CPUs, you're paying for that every hour. And what if you're only using 20%? Why do you continue to pay for 64 CPU when 32 might be enough or 16 might be enough? So one of the things that I always tell people when you're in a cloud system, whether it's IaaS or PaaS, don't only monitor for the ceilings, right? That top 80 to 100%. Monitor things that are in the bottom third as well, because you could be significantly over resourced on some things. And using something like this to track it can be helpful.
Just for those two DMVs, are those specific to Azure SQL Server, or is it managed instance as well?
They are specific to SQL database and Elasticals. Yeah, they don't work for managed instance. I know, because SQL MI has so many other tools that are just equivalent to SQL Server, and you can run agent jobs to capture other data. So yeah, I have asked multiple times, right? Submit that feedback to the SQL MI team. Please make these available. Yeah. So monitoring, right? Every cloud system is also going to let you set alerts. And these are things you should set for both your virtual machines that you're running and again, kind of looking specifically at Azure SQL Database, Azure SQL Managed Instance, really any cloud resource. You're going to be able to go into that resource and say, hey, if my CPU goes over 80% for more than 1 minute or more than 5 minutes, send an email to SQLDBAs@company.com or send a SMS text to this number. Often, there's also other webhook integrations, right? Fire off this PowerShell script, run this Azure function, that sort of thing. This is kind of ties directly into what I was just talking about. You definitely want to go ahead and set alerts on your cloud resources, because this is built right into the system. This is something that is a very quick savior, right? Again, CPU is spiking, your connections are spiking, your deadlocks exceed something. I just realized this is why I wanted to share probably why I should have shared my screen instead of my slides, because let's take a look at some of these resources in Azure portal. I'll give you just kind of an idea of what we have here. Maybe searching for just SQL in my subscription was not the best, most selective filter to start with. So here I have database in here. Yeah, so let's just take a look at one database. When we come to monitoring, we go to alerts. I don't have any on here right now, but I will get there quickly. So here's one that I have set up that covers like high CPU, right? So this is an example of an alert you can set. In this case, if my CPU percent goes greater than 90 for over a minute, I will get, so let me walk through and create a new one because that'll be better. So what you'll get is an option on what signal you get to pick. So any cloud level resource is going to emit signals at the control plane level, right? This is the CPU used, the memory used, the IO used, the connections made to it, that sort of thing. So look through and see what you need to or want to alert on. Again, the basics are still the basics here. You don't need to get extra fancy because you're in the cloud. I use CPU percentage a lot because that's one of the most expensive resources. And this is where you say the average is greater than, again, 80%, 70, 80, 90%. You can set a time frame, check every X amount of minutes, look back for 1 minute, look for 5 minutes, look for 15 minutes. It kind of aggregates that. And these are the places where I say, don't just look at that top 20 to 30%, right? This is in place where it's equally useful to set that kind of bottom threshold to make sure you're not over resourced and paying for way more than you need. Because say you are only using 20% of your CPU, shrink it down. If it gets busier in 2 months, you're in the cloud. You can very easily scale back up, but not pay for that during the time you don't need it. And then once you have that set up, you have all these actions you can do. Again, quick things. You can send an email. You can email a specific group of people. You can send a notification in the Azure app. You can also create a new action group that allows you to, send an email, send an SMS text, and then mobile app notification. You can even make a voice call that would read the list of yours. So I think alerts are cool. Again, I'm primarily used to the alert system in Azure based on Azure Monitor, but I know that they exist in AWS. I know that they exist in GCP. Use these alerts to your benefit. And then I'll just go on to the slides.
And don't set them necessarily the same that you set them on-prem.
Yeah.
Right, like if you're on-prem and you're running at 100% CPU, you might have just crashed your Windows operating system. That's not gonna happen with the platforms, right? We're gonna throttle you after a certain amount of time, right? But there's nothing to crash at 100% CPU because it's fake, right? So it's not like you're tanking the operating system and now you need a DAC to access it and to do anything, right? So you typically run higher in your alerts because you're paying for it.
Yep. And yeah, again, just using the CPU example, right? On-prem, we build a system, we build a server that we're expecting to last 3 to 5 years, right? We might set it so that we are at that lower end of the resource consumption for the first couple of years and then can fill it up. And again, when you're in a cloud system, you're paying for it from day one. So you start small and scale up over time. All right, so now let's talk about, right, so say that we do have a system, a database, an instance, a server that is experiencing some performance problems, right? What are tools we're going to use? So basics that have not changed. I've already mentioned things like your plan cache, your execution plans. Those are internal to the database engine. Those are going to be the same regardless where you are. We find our top CPU consuming queries, our top read heavy queries, most frequently run queries. They're have bad plans. They're generating missing index requests, right? What are we going to do to tune them? I'm always going to turn to my advice, which I've been giving for many years in many presentations, which is a bad query is always worth tuning. Just because you have moved into the cloud and there is a system managing maybe your database patching or taking your backups for you does not mean that it is just taking over management of all aspects of your database. Generative AI is not that good yet. Someday, hopefully, not quite yet. So yeah, bad query, even in 2025, even in the cloud, especially in the cloud, you want to continue to have a system for monitoring your queries and doing it on a regular basis. And if I can just move forward past this one, I'm always going to talk about indexes, right? Indexes are still one of our primary tools for improving query performance in SQL Server. Hands down. I have this discussion with DBA teams every month still, right? Are we indexing properly? Do we have our clustered indexes? Do we have appropriate non-clustered indexes? Are we using include columns? Are we consider, I was talking about filtered indexes a couple weeks ago for the first time in a while. I don't know if any of the old timers remember my index presentation that I used to give, but I loved it. So we're all using row store, but who here uses column store indexes in any of their SQL Server databases? Okay, who here has a database with at least one database that has at least one table with more than 1 million rows? Okay, okay. So we're candidates for column store indexing. So column store is not just, right, this is not a session on column store indexes. We could go back there, bring me back in 6 months, we'll talk about it. It's not just a different type of B tree index, right? This was a rewrite of how the data is stored on the data pages. Data is stored per column rather than per row, which means you have, right, 1 million plus rows that are all the same data type. Advanced compression algorithms run. There are row groups, group them all together. There's a bunch of benefits you can get from column store indexes. Number one, when you have significant compression. So does anybody here use row or page compression on some of their larger databases? Okay, great. Row compression, page compression, they reduce the size that your row takes up on disk. So if you're using less space, your database uses less storage and also remains compressed when you read into memory, which means that you're taking up less space in memory. Reads are faster, queries are faster. All of this also follows through with your column store indexing. Column store can give you up to 10x data compression, even over other compression methods in SQL. And again, it's not just, so it will, especially for those of you that have large tables, large number of rows, a large amount of space on disk, it can reduce the space you're using and reduces the amount of data that's read into memory. And you need less memory, you have faster queries. Again, all of this directly translates into those cost savings. When you have 10x data compression, your database, instead of being this big, maybe you can bring it down that much. Again, this shows up in your company is seeing these in your bills every month. Again, when you have to look at your storage and say, yeah, I need X amount of IOPS. What if you can reduce that by 25% by enabling some column store compression? So there's a bunch of different flavors of it. So column store was introduced, keep me honest here, Tim and Jared, first was in 2012, when it was a very basic.
Non-clustered was 2012.
Non-clustered 2012, then 2014 got more features and they keep adding to it. So modern systems, you can have a clustered column store index, right? So that's similar to a clustered row store index where it's all of the rows, all of the columns is the table. It can also then have additional like non-clustered row indexes built on top of it to support specific queries. So if you have tables that have a lot of writes, right? Especially, does anybody have just logging tables, archiving tables? Those might be great. As append-only tables, right? Those are great choices for something like a clustered column store index. Data warehousing, if you have any systems where you're doing data warehousing style queries, again, lots of rows, historical, appending a lot of data rather than like transactional systems that change a lot, great use case for a clustered column store index. Now, on the other hand, if you have a purely transactional system, but it's still a large table, you do need to do a lot of inserts, updates, deletes to it. And we've all heard this one before. I'd like to run my report in production because I need the latest copy of the data, right? This is actually a really good case for taking your just traditional row store clustered index table, and you can build a non-clustered column store index on top of it. Especially if, and that is really good at satisfying like reporting style queries that do large range scans. And then offloading that from your, clustered index. So again, I would say this is one of, let's see, I think I had, I think I just copied this straight out of my column store index. There's also a thing when the query optimizer chooses to use column store indexes, the processing is now called, so there's now two modes of processing. There's row processing and there's batch mode processing. There's a lot of like intelligent query processing features around batch mode that improve how joins are done, how selectivity is done, that sort of thing. So there's just a ton of benefits for, again, large tables, append only data warehousing scenarios for this clustered index, clustered column store, and also that kind of hybrid transactional analytical running reports in your transactional database systems. Again, direct impact on size of storage needed, amount of IOPS needed, making our queries run faster. Questions on indexes before I move on? Okay. Yeah, I could wax poetic about indexes for the rest of them, but that is not the session. So read scale out. This is another thing I want to talk about, and using this to your benefit, again, especially in the cloud. So when I think read scale out, what I mean is you have your primary that accepts all your read-write connections, and then you're scaling reads out to multiple secondaries. And typically, we accomplish that for using SQL on-prem or SQL in VMs through availability groups, using our readable secondaries, synchronous or asynchronous. This is still a great choice for your IaaS workloads. Offloading reads to a secondary frees up that primary to process the reads, the writes, reduces contention. It also could give you, again, instead of having this one massive VM that has to have all of the CPU and all of the memory and all of the storage managed, all of the IOPS for both your write workloads and your read workloads, it may be more effective to have multiple replicas to break those up and be able to bring those down to slightly smaller compute sizes. And when you're in Azure SQL, whether you're using SQL managed instance or SQL database, there are some of the tiers that actually have this availability group basically built right in. So that's something to note when choosing a platform as a service offering. I mentioned earlier, sometimes those cloud PaaS offerings like seem more expensive, right? I've had people go like, wow, this VM with 40 cores is X amount per month. Business critical with the same amount of cores costs twice as much. I'm like, yes, and you're getting multiple availability replicas built in. You're getting, so I'll walk through that here a little bit, just talking about the Azure offerings. But again, use the availability groups, use your secondaries. Don't forget application intent equals read only in your app string.
But Jess, is that automatic? If you've got one of those tiers with Azure SQL and you code application intent read only, is that all you have to do?
Correct. Yep.
No read only routing or anything?
No, you don't have to set up anything. When so I've set up a lot of availability groups. I've set up a lot of listeners. I've set up distributed availability groups. I've done the DNS dance more than once. And the first time that I realized that I could go into Azure SQL database and deploy what was new that time at Business Critical, and it built an availability group for me. And all I had to do is give it a name, and I never had to set up any routing. I never had to set up any listeners ever again. I was like, this is worth the price of admission alone. Because it really is that easy. Like, it just builds it in the background. So yeah, this is specific to Azure SQL Database Premium, which is the DTU, Azure SQL Database Business Critical, and then Azure SQL Managed Instance Business Critical. So that's a service tier, and these all run, as you can see, like it's an availability group in the background. So there is, in one region, there's your primary replica, and then minimum of 3 other replicas that are synchronous for managing maintenance operations, high availability, and offloading your reads. And again, this is built in. This is not something that you have to, you're paying for it, but you don't have to set it up. You just code that into your application string. You're going to have a endpoint to connect to, and that's it. Also, if in Azure SQL database, if you build a failover group to go like cross region for disaster recovery, it'll give you a failover group endpoint, which can also use application intent read only. And so those two things can work seamlessly together. I will not go into, this is not a DR talk. We also have the Azure SQL Database Hyperscale tier. Has anyone used that yet? Okay. So Hyperscale came out as Project Socrates a few years ago, and I think Hyperscale is really cool. What we have is, rather than, if we go back a couple slides, right? Rather than, yeah, you have a replica that has your compute. It's running the SQL server.exe. It has your buffer pool. It has your plan cache. It has your log file right in there. It has your data files, all of that in one node. Hyperscale is a distributed architecture. So you have your compute node. This runs SQL server.exe. It has CPU, it has memory, it has your buffer pool, it has an RBPEX, so a remote buffer pool extension in it. Essentially a completely separate set of VMs. Whoa, that's way out of there. Runs the log service. So you have a dedicated machine that handles your log service. This gives you higher throughput, like significantly higher log throughput than any other tier of service in Azure SQL. And right, in business critical, if you have 4 CPU, you get like 48 meg of log throughput. And if you need more writes, if you need more write throughput, you also have to increase your CPU. Hyperscale is different. It doesn't matter if you have 4 CPU or 128 CPU. You are going to get up to 150 meg of log throughput a second. No questions asked, no further configuration needed. And then there's a, there we go. Okay. Your data is held in a, rather than SQL server.exe up here, reading off of data files on storage, it pre-warms a buffer cache called the page servers. Your entire database is in a page server at all times and able to just read off. So Hyperscale is really cool. I use it at several customers, and they're very, like, it's fast, it's great. And it lets you also do multiple synchronous high availability replicas that you can offload reads to. The other feature that it has that others don't is called named replicas. So these are all sitting on the same logical SQL server. They all have the same connection string. They all have the same username and password. I can then build named replicas, 1 through 4 over here. They can be on a completely different SQL server. So they have a different logical connection point. They have different users, and they can have a completely different service level objective. So if I just need that for some light reporting for my business department, I can set up a named replica for them, give them 4 cores, give them their own connection string, and it doesn't impact this at all. And you can have up to 30 of those. So if you need massive read scale out in the cloud, SQL Database Hyperscale is the way to go. It's pretty cool.
It used to be prohibitively expensive. It is no longer that.
Correct.
I don't want to hijack her. Oftentimes it's cheaper than the other tiers.
Yep.
And the other thing I'll say really quick about hyperscale is when it first came out, it was advertised as like, this is what you need if you have terabytes of data. And so everybody thought, I shouldn't use hyperscale unless I have large amounts of data. And that is the wrong way to think about it. You should use hyperscale pretty much no matter what, unless there's a reason to not use hyperscale. It's the way to go for cloud native, for modernization. It's just, it's what I'm recommending to all my customers who are in the category where they can use SQL DB. Don't go and use DTU. Don't go and use this, use hyperscale.
Yeah, and I have, again, enterprise financial services customers that have now standardized on any new development, any new databases that go into this, go into hyperscale. So it's being adopted by big companies. That is also zone redundant, but I won't talk about that today. Okay. So again, use your read scale out, and you also can do, in addition to your horizontal read scale out, right? Let's talk about vertical scaling here a little bit, because I want to touch on a couple things I've kind of mentioned. Again, when you're on-prem, when you're in physical hardware, you're speccing out this server that's going to last 3 to 5 years. So you build it big. And again, you might start using a small amount and build up over time. In the cloud, start as small as possible. Keep it as low as possible as much of the time. You have the ability to scale up and down at will. You can do it manually if there's a sudden surge that you're unprepared for. You know, some influencer touts your company product and it goes viral, and all of a sudden nobody can keep up with you. Or it's peak season, right? Your retail company and it's, you know, October to January, or you're a tech and it is Jan 1 to April 15th. So how it works, right? So scaling your platform as a service offerings, what they do in the background is they don't actually close connections on your existing database and change it. It actually creates a replica, syncs all the data at the new performance tier that you want. It syncs all the data over, and then when it's ready, it just flips over the connection. So no data is lost, no transactions are lost. When it goes to do the failover, right, it might reject connections, which is why we say always have connection retry logic built into your applications. Developers, please. I'm sure we've all had that discussion before too. But a couple of things, I won't talk too much about limitations. I would rather focus on, so you can scale, again, in Azure, you can use the GUI tool, you can use the API, you can use coding languages. Heck, you can even do it from within the database itself using T-SQL. Again, you can do it manually. You can also do it like on a schedule. And that is what I suggest. So again, back end of last year, I was working with a customer where they were having they had like 8 Azure Data Factory pipelines that ran overnight, right? Starting at around 11 p.m., went for about 4 or 5 hours, fed the data into their system, then quiet for a couple hours, users come in, use it, 7 a.m. to 5 p.m., quiet for a few hours. They had their databases cranked up to 80 CPUs 24 hours a day, because that was the level of compute, memory, and IOPS they needed to hit that max bandwidth overnight. And then as soon as the batch load was done, tanked. And during the day, it went up just a little bit. Users read, and then again, 11 p.m., resource consumption. But they were keeping their resources up here all the time. And so went in, talked to them about scheduling. We built some automation into Azure where on a schedule, right? 10 p.m., right? We want to do it a little bit ahead of time to give the database or the instance some time to warm up. But you were able to, I would have them go from there. I don't know if they did like 32 or 40 during the day, but they would build it up to 80. Keep that for for 6 hours. So 4 hours of batch processing, little buffer on either side. And they built in some automation, like if my Azure Data Factory pipeline runs are done, as long as they have completed, then scale it back down. Users come in, everything's working fine. It was something like a 30% cost reduction on their most expensive SQL database. And that is the power of the cloud, right? Those are the things with those platform as a service offerings, and even IaaS, where if your patterns are consistent like that within a day, within a week, a month, again, seasonally, retail, taxes, financial services companies have defined, have benefit season coming up, right? Enrollments. So I'm working with a couple of them and like, what's our game plan for that? So in addition to read scale, when you're in the cloud, you have that elastic ability to go up and down. So definitely do that as well. I won't go into this too much. You can also use serverless databases. Serverless databases are a type where if you have absolutely no activity for a period of time, it'll shut the database down and you only pay for the storage at that point in time. Really good for databases that are used a couple days a month. Archive databases where someone might need to connect to it to report a couple times a month. And there's also some options in like SQL managed instance where you can just totally stop the instance and restart it. Great for like dev test environments, non-production environments. Again, another option to save your company money in the cloud. So that's kind of my quick chat on scaling. I'm a couple minutes over. I think the last couple of things I wanted to talk about, Query Store. I've talked about that a little bit. Query Store, in my opinion, when you create an Azure SQL database or an Azure SQL managed instance, Query Store is enabled by default on all of your databases. We run Query Store for millions of databases of millions of sizes with billions of transactions a day, to your point, without problem. It should be the default on all of your SQL databases. It is that black box recorder for everything that's happened, and lets you find a lot of issues.
We like it so much, we put it on Postgres and MySQL too.
Yeah, yeah, literally, Microsoft built a Query Store for Postgres in Azure and MySQL in Azure, which don't exist natively. You can't get Query Store for Postgres in AWS or in, yeah.
I do.
One thing,
Postgres does have something similar called perf stats, but
Query Store is better.
it is.
Yeah. One of the things I will say is that Azure SQL Database does have another tool built on top of Query Store called Query Performance Insight. And I think it's unfortunate that this is only available in SQL Database. I wish it was made available for more things, because for those of you that have used Query Store, you're used to connecting to SQL Server Management Studio, using the very bland graphs in there, maybe rolling your own by querying some DMVs. Query Performance Insight is this, I find, much more intuitive, much more colorful, much easier to see tool in the Azure portal, which if I had a database that I could run a workload against right now, which I don't, I could show you more live show, but here you can see it gives you, much like Query Store, top 5 queries by CPU, by data IO, by log IO. You can set a custom time period. I think it's as little as the last hour, all the way up to however long your Query Store settings are. And you can see it's very graphical. Here we can see that this yellow query was the one doing most of the work over this period of time. We come down here, we see the query ID. What we would do is we would click on that query ID and it would pop up another page that gives us the query text. It gives us the average resource consumption, and it even breaks down within the last 24 hours, bucket by bucket, how many times that's run and what resources it used. I think Query Performance Insight is great. And it also feeds into some of our newer like automatic tuning features that are available in the platform as a service offerings, because they're running in Azure. We can run some ML things on them. So it does things like gives you recommendations on index creation, dropping indexes. And I think a cool one, which much to my dismay, I realized is still in preview, checks parameterization. And if you have a heavily like a database where there's a ton of parameterization issues, it will enable forced parameterization for 24 hours, check it and see if that improves it. And if so, it'll keep that on. Again, kind of a self-tuning. AI is not quite fixing our databases entirely, but when you're running in the cloud, there are some things that with all the telemetry behind all of the things that are feeding in, cloud providers can monitor. This is one of them. And so, yeah, you get issue or recommendations like that for. And this is not something where you have to hunt through and say like, okay, this missing index request is coming from what query? Is that even worth it? This is saying, I looked at my top queries by data IO. This query far and away was using the most over the last week. I go into that and it specifically recommends that I create this index for it. Here is high impact. Let's put that in and test it.
Which team creates our little graphic?
I don't know. They're very old. They've been around a long time. Yeah. And I can, right, there's a blog post from Jim Donahoe back when he wanted to use this, or when he first started using this, he worked with a customer, used it to find the top 5 resource consuming databases and queries in them. The top 3 queries they identified reduced the load on that system by 10 billion with a B reads. Like that's not insignificant, right? Like that's significant. And that was also one of the things that made me go, query performance insights, killer. All right. Last thing I'll touch on briefly, again, Azure SQL Database has this, again, ML-driven, telemetry-driven, data-driven feature called automatic tuning. And if you enable this, if you have databases where you don't have time to hold every developer's hand, teach them how to build good queries, show them how to write good indexes, you don't have time to manually convey this all the time. Automatic tuning is a great feature because it will create some of those missing indexes. And it doesn't just create them and let it go, right? When it creates an index and it monitors it for a period of time to make sure that it had the impact that it expected. If it did, it will keep it. If not, it will disable it. It will also go through and look at unused indexes in your database, right? Unused indexes, they increase the number of writes in your system and they, again, taking up extra storage. So it will drop unused indexes after a set period of time. And it will also do a thing called automatic plan choice correction, which is, it looks at Query Store, looks at all of your query plans. And when you're using Query Store, if you notice a regression and you say, hey, this query was running fine yesterday, it's terrible today, I can just go into Query Store and pin or force that last good plan. Automatic tuning takes that up a step and it does it for you. So it's like the next level of automation within Query Store. Again, a benefit you get when you're in one of the platform as a service offerings. So it's again, Query Store, Query Store, Query Store. If I haven't mentioned Query Store, if you're not using Query Store, if you take one thing away from this session tonight on perf tuning, Query Store, please. Yeah, okay. I went through a lot. So thank you for my attending my TED Talk tonight on the crash course of perf tuning in the cloud. Any questions?
No questions?
I'll hang out for a bit, but if anybody needs to rock and roll, please feel free. But thanks for coming tonight. This was good. Yeah.
I'm curious because I work right now, the orgs that I'm working with, I think might be an anomaly, but they may not be. So I want to ask around. How many of you are seeing the decentralization of database administration and it being put in what I think is a misunderstanding of DevOps, but it's being put onto the application teams, where the application teams are they are now responsible for owning the data tier, monitoring it, understanding how to maintain it and all that kind of stuff that typically a DBA would do outside of probably the other stuff they're doing with infrastructure. But I'm more worried about the data.
I mean, I guess the question for you to go deeper, is that like, you're talking like a data team owning everything in a small company for sure?
Yeah, so like, I think what I'm used to, right, is traditionally there's a DBA team at an organization. Maybe they have more than one, maybe for some different business units, but it's not like, hey, you guys wrote this app, you will also now be maintaining the database, you're responsible for monitoring the database, right? Non-DBAs, developers, now responsible for maintaining and monitoring their
I
database.
see it, but where I see that, they also have usually a pretty large DBA group, and a DBA or multiple DBAs will be assigned to a business unit. So, yeah, so the business unit is the one that gets the charge back for all the resources that gets provisioned, right? And then,
They're almost like consultants
yeah,
to a
exactly.
degree. Okay. Like it, like that,
Nationwide,
better than,
they've been doing that for a long time.
You know, we started to see that decentralized, especially with, we use AWS, so especially with they would go and have a platform team create Aurora databases. And we had a sprawl, if you will, of instances with Aurora databases and AWS accounts. Then our regulators got wind of that and said, hey, DBAs, you have to reel that back in. And we say, we didn't even know they existed.
Yeah.
Like, you know, it's, hey, we need a database. Let's consult the database administration team. Said no one ever.
and you guys are more tightly regulated than even most of my clients because you're a clearinghouse.
Yeah,
I guess what's interesting is like in the warehousing world, right? You use like Databricks, right? So you're talking about all this the SQL stuff, but I mean, half the stuff you're doing is in Python, right? So you're looking at data, you're looking at Spark, right? How do I look at clustering and all this other stuff like that? So it's a, you know, like a traditional DBA is not going to be great at tuning a Spark query.
Yeah, I agree. I'm a traditional DBA. I look at some of that stuff and I'm like, phone a friend. Yes, absolutely.
You know, so I don't know if having a DBA looking at, you know, especially when you're in Databricks and like half of what you do is Python, half what you're doing is SQL.
Well, and certainly because the structure is different, right? I mean, you're talking, in Databricks, you're talking about essentially files, right? It's a data lake. And so you've either got Parquet, Avro, JSON, you know, something like that.
Your Delta Lake, you know, your Delta tables.
Yeah.
Right?
Which is Parquet, right? With a JSON transaction.
Exactly.
So, I mean, that is a database in terms of like pure words, right? But it's an application.
It's a-
Yeah. I mean, it's an application tier, so I mean, in that case, typically the application devs are the ones that are.
Kind of like Cosmos DB. Like, I'm like, that's not really a DBA thing, right? In traditional,
Like,
it's a developer.
look, I mean, like you're gonna look at Reddit. I mean, like I think Netflix was like an example of a company that uses not just SQL Server, but they use like Redis for certain things. They use a graph for certain things. You know, Cosmos for certain. Because I mean, you know, right? You have to kind of have all these different databases to run your business because they all have different purposes.
Right.
So I guess, and maybe I'm not answering saying this question the way you're proposing it, but I kind of feel like, yeah, your DBA is going to know that SQL, great, but these other databases are kind of not the same thing. So
You're right. I'm
Is it wrong to
strictly
answer it?
thinking about relational, right? Where these types of things, like Jess said, a bad query is always worth tuning, right?
yes,
That's not always the case when you get to outside of relational, because what's bad and what's not kind of takes on a different thing.
like Cosmos, like how you partition things,
So that's probably the most important thing,
right?
right? Is how you
I
partition.
mean, like, again, with Spark, the questions are going to always be like, it's spill and the 3 S's, right? Or the 4 S's, right? Spill and I forgot the other ones, but you know what I'm saying?
Yeah, and that's different from relational databases.
So, I mean,
Different lakes.
Tuning document store, right? Versus a relational database.
When you think DBA, it's relational.
It's relational.
Relational.
Yeah.
mhm.
I'm thinking Oracle, SQL, maybe MySQL, Postgres.
Yeah, I feel like companies nowadays have to be so, you know, you as an employer almost having to kind of like be a master of everything. Jack of all trades, master of none kind of thing.
Well, which is quite frankly where I'm seeing most of the problems.
That is why you feel most of the problems.
Yeah. Because nobody can be a master of everything. Well, some people can.
Well, I mean, I feel like consult, like the best thing Microsoft did is put like all these like the business can build all this stuff in Power Apps and Power Automate. Like, yeah, they can build it to some degree, and then somebody has to go and fix it. They can POC it, and then somebody has to then, the consultants come in there and have to fix it all.
It's like I was like entity framework, great for small shops, right? But it doesn't hold up at scale. I should say, code first entity framework doesn't hold up at scale because essentially you end up having if you're familiar with entity framework, you have all these ORMs that build these tables with GUID data type as the primary key, and they wonder why things start to slow down, why they get fragmented indexes, right? Versus database first. So it works on a small scale, doesn't really work on a big scale. Code first. Huh? I know you don't, fine. It's still GUID data type on every freaking table as the primary clustered key. Causes its own issues, right? But that's just one piece. That's just one piece of entity frameworks. Interesting things. The other thing I wanted to say is, even though I'd love to have Jess come back in 6 months to talk about Column Store, if you want to see something on it sooner, I was looking back because I thought that I had done this. There is a video on our YouTube channel where I did a session on Column Store indexes, and I don't think much has really changed since then. Back in like 2021.
Yeah, there shouldn't be major.
So if you look here on July 8th, 2021, there's a section on column store indexes, because Josh gave you a nice little overview, but it goes deep, and it's great bedtime reading. I like to think. For some reason, I get excited about column store indexes, and then multiply it times 60, and I really like it.
So that's for story time for your kid?
Yeah.
That's good.
Dada, can you stop talking now? Anything else? Did we spark any questions for Jess?
Well, I hope everybody learned something. I hope everyone has something to take away to their current environment or their next environment. And again, yeah, if you have questions about things like query store, column store indexes, like implementing even some of these things in the database engine, regardless of where it sits, like please reach out to me via email or LinkedIn if that's easier. I would love to send you resources, help you out, figure out if it, again, I would love to have you evaluate query store again. We are running it millions of databases every single day, no impact. Major financial institutions, high transactional systems running us.
I want to use it for this one particular regression that we get, and the solution I have right now is I run a job that looks for like query metadata where there's been a certain number of reads and then executes a recompile.
I mean, I've seen.
It's working fairly well, but I would like to avoid it.
Sounds like is it a parameter sniffing issue?
Sure, parameters.
It's a coding issue. Not what I could
Recompile is your,
try that.
you're doing the same thing with.
We did option recompile on the problematic part,
Uh,
and it still reverts sometimes. And so monitoring it still catches it like
Version
10
of
times a week.
SQL, are you on? What version of SQL?
2022.
So option recompile makes it so that the query is not cached. So there's no caching, so there's not a reversion at all. It's just.
Well, so maybe the actual recompile isn't helping, but it's still catching the reversions.
Should be a statistics thing.
That's interesting.
We run a daily set of statistics updates to try to address this. It's been something we've been working on for years.
In 2022 will store multiple plans. So if it's not
It's a query that goes through the
parameters,
record system and gets the doctors all the things they need to sign off on from different areas.
is it a procedure, and is it really big?
Yeah.
Probably timing out and running serially.
But I mean, still, we optimize per statement, not per product. So that wouldn't matter.
The latest
Oh.
fix from the vendor was a option recompile for the problematic query and the store procedure. But you know, I think it is still a reversion because when it happens, it affects all providers for a while, and then the recompile makes it go back.
But you'll never see that in the plan cache, but Query Store would capture it because it has even though it has.
I'm looking at the query store to say, hey, never, always use this particular plan.
You can.
You just gotta be careful.
Sorry.
So when we think about parameterization, right? So the way SQL works is on the first execution of a statement that's parameterized.
Yeah, I got that.
Not local variables, just parameterization.
Understood.
Then it caches that plan and it reviews that plan. Well, an after recompiled plan isn't gonna get cached, so there's no parameterization issue after that. At that point, you either have a local cardinality issue, which uses the average density, or that histogram, or here's the side of it. So it's gotta be one of those two. Could be choosing a bad plan, could be missing an index. Well, whenever it does that, though, it could choose the wrong joint choice and spilled index and there's a bunch of well.
It's like if there's 4 million reads, I know. You got the.
Yeah, it's very great.
I would try to see like what the difference is between those plans, but you can capture them.
Try to figure
I
out
have for
like
years,
what's
yeah.
causing it. Cause that's and maybe like you said, it's statement level. I had a customer at one point where they just had a giant query and the optimization phase just kept timing out. And what we noticed was it was sometimes choosing a good plan and sometimes not for the same.
Yeah, it's certainly.
And what it was, is I said, break this apart. Well, no. If you could fit everything into a single query, that's always better.
No, that's
Because somebody told them that,
always
right? Because somebody told them that. And I think what we did was we broke something into a temp table so that we persisted it. And there was, I think, also a misunderstanding of local variables and the 30% rule
Yeah.
versus using statistics.
for equality searches. It's not for equality searches.
Right.
Also wanted to real quick introduce myself.
Yeah.
It's my first time at one of these meetings.
Welcome.
My name is Brian Garrity. I've been an active member and used to help lead like a past chapter back in Virginia Beach where I'm
Oh, cool.
from. I moved to Chicago in September of 24.
Okay.
And just a couple months ago, I was like, I got to figure out what's going on in SQL world here. And so, I've spoken at SQL Saturdays. I've spoken
Sweet.
I've spoken at like local user groups, code camps, that kind of stuff. Been to many past summits.
Sweet.
Anyway, so just happy to be here. Happy to meet you all.
Happy to meet you.
In SQL for 25 years.
Awesome. We are formerly known as PASS.
Yeah, I figured that it's probably now.
SQL.
Shy SQL.
Yeah.
Are you, is it an Epic system or is it different?
It's a product called Next Gen.
I haven't heard of that one, because I used to work with a lot of customers that ran Epic.
Yeah.
Worse.
What, Epic?
Yeah.
But everybody's got it.
We're actually only on this system until November.
What do you mean after you say Chris? Well, no way it works.
It's like SharePoint databases.
Right.
Ask the one.
How do we stop? Just
Yeah.
stop one for every.
Did you enjoy your first Chicago winter?
I actually did. Yeah, it was nice to have a real winter.
What are you talking about? We haven't had a real winter